So in summary for statically determinate beams then, if we have a simply supported beam, we have three unknown external reactions, so a vertical reaction at A, or a vertical and a vertical reaction at B, where this is A and this is B. And we also have a horizontal reaction at A. And we can solve if we have let's say we have a general load which comes on at some angle, which has a component in the, if we remember our vectors, we have a component in the vertical direction and a component in the horizontal. So this is P in the horizontal direction and this is P in the vertical direction. So from our vector resultant force for P, that has these two components, which is P in the horizontal and P in the vertical. Those forces have vector the vector's sum of those is equal to the vector P, okay? Where those are orthogonal forces in the x and the y direction. So solving the three equations, sigma horizontal, or sigma in the x direction, but we've labeled it horizontal and vertical here. So sigma, the sum of forces in the horizontal direction are equal to 0. So R A H is equal to the horizontal component of P. That's our first equation. R A V plus R B V is equal to the vertical component of P, or if you like, the sum of them is equal to 0. So that comes from our second equation of static equilibrium. The forces in the vertical direction are equal to 0. And then the sum of moments about a point, and we'll take that point as A in this case. We can therefore work out that this point acts at some distance, and the important thing is the perpendicular distance. So it's that distance there, x, from the point A. So this resultant force coming through here has a direction which has some lever arm distant from A, and then we can take moments about that and find that the sum of the moments about A are equal to 0. So this force has some lever arm x there, and that's balanced by this force RBV times the length of the beam. Okay, so those are the general principles for a statically determinate beam structure. We have 1, 2, 3 unknowns, and we have available 1, 2, 3 equations of static equilibrium. Okay, if we have a situation where we did away with this roller here, so if we get rid of the roller bearing at that point and make this another fixed support, both in the vertical and horizontal direction, we introduce another horizontal reaction, which we'll draw to the right, These are pinned supports, so we say that they can't generate a moment reaction at those points. So we say that we cannot generate a reaction in moment about either of those supports. But we now have a situation where we have 4 unknowns because we've introduced this extra horizontal reaction at B, and we have 4 unknowns and 3 possible equations for the overall static equilibrium of that structure. So the number of unknowns, or the number of unknown reactions, is for pin joints 2 per joint, and the possible number of equations are 3. Therefore we say that this beam is now indeterminate using statics alone. So in terms of our equations of static equilibrium, we don't have enough equations to have simultaneous equations sufficient to solve for all the unknown forces. So we say that this is statically indeterminate, and the degree of indeterminacy is equal to 1, because we will have 1 extra force than we do reactions. So if a beam is statically determinate, the degree of indeterminacy is 0. If, for example, we only had 2 reactions, so if we had a beam that only had 1 support, so we had a support in the vertical and horizontal direction here, but this was a free end and that was a pin, any load on it would just give rise to a rotation of that beam, and that beam would just sort of drop down under the load. It would just rotate about this point here, so it would not be in static equilibrium, so it would become a mechanism, and the degree of indeterminacy there would be -1, because we have only 2 unknowns and 3 equations. So we have 1 fewer reactions, or 1 fewer unknown forces than we do have equations to solve them. So if you get a degree of indeterminacy of negative number, then that means that essentially you've got a collapse mechanism. So you are not in in static equilibrium. For full static equilibrium, we get a degree of indeterminacy of 0. So that is statically determinate. So it's both in static equilibrium, and we can determine all the forces, all the unknown forces from the equations, because we have an equal number of both. And if we have more unknowns than we have equations, then we end up with a degree of indeterminacy of the number of unknowns minus the number of equations. So if we had 4 unknowns and 3 equations, we would have a degree of indeterminacy of 1. Okay.